Hello and welcome to yet another video of Cornerstones of Math. In my last video, I have solved this equation containing golden ratio phi at the powers. You can find the link in the description. Then it occurred to me, hey, why don't we make a function out of it? So in this video, we will deal with the function. Consider a function fx defined as x to the power of 2 phi minus x to the phi minus 1 defined on x greater than or equal to 0. Here, this phi, which has a value of 1 plus square root of 5 over 2, is the golden ratio, which happens to be the positive real root of the equation t squared minus t minus 1 equals 0. Find the value of x that minimizes function fx, the minimum value of function fx, and the inflection point. Alright, so in order to find the minimum value, we first have to obtain derivative. So let's take derivative. Then we have 2 phi x to the power of 2 phi minus 1, then minus phi times x to the power of phi minus 1. Here, notice that we have the common part phi x to the power of phi minus 1, which is also hidden in here. So if we write phi x to the power of phi minus 1 at the front, then we have 2x to the power of phi, then minus 1. So you can see that the derivative f prime x becomes 0 when x equals 0, or 2x to the power of phi minus 1 equals 0. When x equals 0, the value of the function at that point is simply minus 1. When 2x to the power of phi minus 1 equals 0, then we have x to the power of phi equals 1/2, so x equals 1/2 to the power of 1 over phi. And using the value of the golden ratio phi, which is 1 plus square root of 5 over 2, x equals 1/2 to the power of 2 over square root of 5 plus 1. And if we rationalize the denominator, we obtain 1/2 to the power of square root of 5 minus 1 over 2. Now let's find the value of the function at this x value. And let's use the phi expression again. Then the value of the function is f of 1/2 to the power of 1 over phi, which is 1/2 to the power of 1 over phi to the power of 2 phi minus 1/2 to the power of 1 over phi to the power of phi minus 1. And notice that phi cancelling out and phi cancelling out. So we simply have 1/2 squared minus 1/2 minus 1, which is minus 5 over 4. Comparing with the value f0, you can see that this is the minimum value of fx. In other words, fx has the minimum value of minus 5 over 4 at x equals 1/2 to the power of square root of 5 minus 1 over 2. So that was the first part of the problem. Now the second part, the inflection point, where the curvature of the function changes. It is the point where second derivative is 0, so let's take second derivative. From this derivative that we previously obtained, the second derivative is 2 phi times 2 phi minus 1 times x to the power of 2 phi minus 2 minus phi minus 1 x to the power of phi minus 2. So notice that we have phi x to the power of phi minus 2 here, and phi x to the power of phi minus 2 also hidden in here. So we can take out the common factor phi x to the power of phi minus 2. Then we have, from here, we have 2 phi minus 1 x to the power of phi, and from here, minus phi minus 1. Here, this phi minus 2 is square root of 5 minus 3 divided by 2, which is negative. So this is negative power. Therefore, the second derivative is 0 when this part is 0. So 2 phi minus 1 x to the power of phi minus 1 equals 0. So x to the power of phi is phi minus 1 divided by 2 phi minus 1. And if we use the value of golden ratio, we have 1 plus square root of 5 over 2 minus 1, and we have 2 times 1 plus square root of 5 over 2 minus 1. So the numerator becomes square root of 5 minus 1 over 2, and the denominator becomes, this part becomes 1 plus square root of 5 minus 1, so simply square root of 5. So we have 2 square root of 5. So square root of 5 minus 1 over 4 square root of 5. And by rationalizing the denominator, we have 5 minus square root of 5 over 20. And this is the value of x to the power of phi. So x is, in phi notation, it is phi minus 1 divided by 2 phi minus 1 raised to the power of 1 over phi, or using the above value, 5 minus square root of 5 over 20 raised to the power of 2 over square root of 5 plus 1. Because phi have this value, which by rationalizing the denominator, 5 minus square root of 5 over 20 to the power of square root of 5 minus 1 over 2. So this is the x-coordinate of the inflection point. Now let us find the y-coordinate. It is the value of f of phi minus 1 over 2 phi minus 1 to the power of 1 over phi. And let us use the expression using phi again, because it actually simplifies calculation due to the nature of raising to the power of phi of the given function. So we have this value raised to the power of 2 phi minus this value raised to the power of phi minus 1. And notice that phi being cancelled, so it is phi minus 1 2 phi minus 1 squared minus phi minus 1 over 2 phi minus 1 minus 1. And now let's substitute with numbers. Let's use the fact that phi minus 1 is this value minus 1, so it is square root of 5 minus 1 over 2, and 2 phi minus 1 is 2 times this minus 1, so it is just square root of 5. So we have square root of 5 minus 1 divided by 2 divided by 2 times square root of 5 squared minus square root of 5 minus 1 divided by 2 divided by 2 times square root of 5 minus 1. So we have square root of 5 minus 1 over 4 square root of 5 squared minus square root of 5 minus 1 over 4 square root of 5 minus 1. So the first term gives 6 minus 2 square root of 5 divided by 40. And for the second term, by rationalizing the denominator, we have 5 minus square root of 5 divided by 20, so this minus 1. And notice that we can divide by 2 here, so it is 3 minus square root of 5 divided by 40. So using the common denominator 40, we have 3 minus square root of 5 minus 10 plus 2 square root of 5 minus 40, which gives minus 47 plus square root of 5 divided by 40. And this is the y-coordinate of the inflection point. Therefore, the inflection point is 5 minus square root of 5 over 20 raised to the power of square root of 5 minus 1 over 2, comma, minus 47 plus square root of 5 over 40. And that was all for today's video. Thank you all for watching. Please don't forget to hit that like and subscribe buttons, and I will see you in another video.